Hi, I'm Leanpub from Leanpub, and in this episode of the Front Matter podcast, I'll be interviewing Leo Tam. Based in San Francisco, Leo is co-founder and managing partner of Amicus Investments, a machine learning research and advisory firm. He founded and launched the NVIDIA Deep Learning Institute, a global educational and professional development organization, and was previously a senior research scientist at NVIDIA and a research scientist at the Stanford University Department of Radiology. You can follow him on Twitter at Leo K. Tam and check out his blog at leotam.github.io. And you can check out the Amicus website at amicus.ai, as well as on Substack at amicusai.substack.com. Leo is the author of the book Truth Engine, Applying AI to Investing. In the book, Leo walks you through a great deal of details about machine learning and neural networks and AI and all kinds of really incredible financial concepts and things like that. So whether you're an expert in finance and investing or you're brand new to it, this is definitely a book that you should be reading. So in this interview, we're going to talk about Leo's background and career, professional interests, his book, and at the end, we'll talk a little bit about his experience as a writer. So thank you very much, Leo, for being on the Leanpub Front Matter podcast.
Thank you, Len. Thank you for having me.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about where you grew up and how you found your way into the career that you've built for yourself.
Yeah, absolutely. It's a little bit of the inverse of Tolstoy's epigram, which is all unhappy families are different. Mine is I spent too much time in school. That's basically most of my life. And I ended up working at NVIDIA after doing well at a machine learning competition at Stanford. So to keep it brief, and I was at NVIDIA almost 6 years. And thank you for that pretty direct overview of my experience. I couldn't say it better myself.
Yeah, and I'd really like to ask you about. So I've spent probably more time than I should have in school myself. I got a doctorate in English.
Yes,
for my
very
sins,
jealous
for my sins. yeah. But you did your doctorate. Was it at Yale?
Yes, it was at Yale. It was in engineering. My advisor was a medical physicist.
Okay.
I had gone into a PhD program, a physics program in University of Chicago. I ended up doing it in engineering because this is already a digression, but maybe an interesting one is the state of physics in these days it's very much dominated by big science, what's known as big science. And this is, I think if you've seen that recent movie on Oppenheimer, the making of the atomic bomb, that's really the genesis of big science, the Manhattan Project. And it's dominated all the way to modern day. That's not quite as satisfying as it can be if you set out to be a scientist, to really own an entire system. And actually, the topic of my thesis, which was MRI physics and machine learning, it gave some of that appeal. And so that's how I ended up at Yale.
Yeah, that's fascinating. I mean, it's one I've had the pleasure of interviewing some people in sort of like areas like that. And I think one thing that's often very surprising to people who, we kind of think of, when we think of like physics and stuff like that, we think of, equations on chalkboards and things like that. But things like machine learning have really changed the way science is done. And like, for example, like, I interviewed somebody who was in molecular biology, and they'd been using sort of machine learning techniques. I mean, I can say the words and sort of draw the picture, but without really understanding it. But basically by analyzing millions of images of cells, they could predict what was going on inside the cell from an image of its surface. I just bring that up as an example of how, like, the kind of work that you would have been doing for your PhD might not be exactly what people would have in mind when they think about like radiology and engineering and stuff like that.
No, that's extremely topical. So one project I worked on at Stanford with Jeff Ullman among others, and Robert Chang, a Stanford ophthalmologist, is diagnosing retinal images, which allows you to monitor the progression of one disease in particular called diabetic retinopathy, which, if untreated, can lead to blindness. And it was one of the early examples of neural networks being extremely powerful. As one radiologist put it, he coined this ancient term, which is one of the most famous radiologist websites, one of these trade websites. It's called Aunt Minnie. And so there's this story between what is an Aunt Minnie? It sounds so folksy. So there was a extremely talented radiologist, probably a department chair at MGH or Harvard or one of those. I forget, it might have been Cincinnati, but You can look it up if you're really interested. But they asked him, these computer scientists were trying to improve their system, and so they go up to him and they say, "How are you making your diagnosis? You're one of the best radiologists in the country, and especially one where maybe there was a subtle type of bone cancer that maybe you could just take a radiograph, which you wouldn't necessarily expect to see a type of bone cancer from." And he said, "Oh, then this person is at risk." And he said, I couldn't tell you. It's as plain as if my Aunt Minnie were in the radiograph." So this idea of that neural networks are getting at some type of intelligence that sort of traditional computer science had not been able to access, which is this more intuitive, more unspoken type of intelligence.
And what did you do after your PhD?
So, if we want to color it in, I worked at a biomedical startup for a time, and that was on continuing from some of my work on MRI gradient inserts. And after that, I went to Stanford as a research scientist in that field, and then I was there a year and a half and did well in this diabetic retinopathy contest, which is a CAGO contest in partnership with the California Healthcare Foundation. And, NVIDIA certainly being right on the ball as it is, we're hiring for that type of skill set.
That's really great. I'm sure everyone listening is going to be a little bit curious to hear about NVIDIA. I mean, it's in the news. It's in the news a lot today for all kinds of very important reasons. What was your time like there? Was it as exciting as it would sound like to an outsider to be working like on the cutting edge?
Yeah, and I appreciate how entrepreneurial your group is, and likewise. So I think we really share this as an interest. It's driven by a co-founder, which you can appreciate, Jensen Huang, tremendously visionary man. When I joined, it still had that startup feel, and people are shocked when I say this. And I feel like at headquarters, there's probably around 2,000 people. In the machine learning focus group, this emerging application of GPUs to machine learning, to be specific, it has this, one of these magical numbers of where it was probably less than 120 people. That's one of those numbers where they say if it's less than that number, everybody knows everybody. So it's like everybody knew everybody working on machine learning at NVIDIA at that time in 2015. And so growing from there very much felt like scaling a startup. This, you mentioned the Deep Learning Institute, something I'm very proud of, our educational initiative around training developers on deep learning, which is, related to the book I wrote, but a little bit more technical. We actually brought people through, we served cloud instances, brought people through environments and created applications. That was a tremendous initiative from the man himself, Jensen Huang. That was his brainchild, so I can't claim any credit for that, for the genesis of that brilliant idea. And it was an enormous pleasure, an enormous run, and it connects to what I'm doing with this current project, because we started out with computer vision, and certainly the second wave was language modeling, was using GPUs for language, which was even before generative AI, and that is something that, at least I believe that thesis, since we started our company in 2021, full out, was born out. Yeah.
Yeah, I'm really interested in sort of diving into some of the details about what your company is doing and things like that. But one last sort of fan question about NVIDIA. Were you working? Sure. Were you working to develop machine language techniques using their technology, or were you kind of working to improve their technology to do machine learning, or was it like a kind of feedback loop?
So, yes, I would say yes to both. So, okay. NVIDIA is definitely, it's like I feel like Jensen should still have me on the payroll right about now. But yeah, certainly they focus on exactly both directions. Mm-hmm. And I would say when I was working on the Deep Learning Institute, I was also, it's like, this dual function, and Jensen's very good at getting the complete information collection ability from his personnel, is to collect. When you teach people and you listen to them, and to be good at listening, you find out I'm sure you can actually appreciate this very much so, is what people are looking for, how to improve the next iteration. Certainly, Jensen subscribed to this idea of always be paranoid, which is this old concept from Andy Grove, the legendary CEO of Intel, and just always looking for the next thing, always looking for your next market advantage. And then when I was a research scientist, which is what I ended up because I want to kind of return to the technical aspect, is then that is very nice is to be a consumer of NVIDIA technology, and to why that is equally important is to drink your own champagne. Certainly NVIDIA invests with enormous resources they have now, certainly to promote that too. Yeah.
And so I didn't know the year, but it was in 2021 that you co-founded Amicus?
Yes. Around June of 2021, we had left. We had done some earlier work in our spare time. I think we have a track record that dates to 2019, for instance. However, I would say the official, crack of the starting gun was in 2021.
And so, how did you find your way into that business? For a lot of people, people find their ways into finance and investing from various paths. I mean, after I finished my doctorate in English literature, I went to investment banking and became, did mergers and acquisitions.
Sure.
It's just, something people are kind of like, how'd that happen? And I'm like, well, not comparing myself to him, but Henry Paulson studied English.
Yes.
And so there's various ways in, but one of the ways in, is from, very sophisticated engineering kind of work and research. The first quant I ever met was a buddy of mine from Aberdeen who was PhD was in getting satellites to look through clouds better.
Right.
And so you can end up in these ways. And so you went from deep learning and machine learning and NVIDIA into finance.
Yes. And so, that's certainly a question we get a lot. And so the best way to answer it is actually, there's no simple answer, right? And this is one of Charlie Munger, who's one of our intellectual heroes, would say it's, the confluence of a variety of factors. You might call it, Adam Smith called it the invisible hand of the market, right? Or, this a variety of factors pushing it. Among those include, one, the technology, right? Certainly transformer architecture is being applied to text. And then really two mysteries that persisted as an intellectual challenge for us, and I think many people are aware of this. One proposed by Charlie Munger, who said when Renaissance Technologies, one of the foremost quantitative shops, when they tried to launch their large cap investing fund, which is the Institutional Equities Fund, RIEF, they weren't able to do it. And this was circa 2008 and 2009. So this is one of the opening stories of my book. And that was a mystery, because these guys, Jim Simons, may rest in peace, who passed away recently, was one of the most intelligent, the smartest mathematician, wasn't able to tackle this problem successfully. And I'm sure it's since improved, but there was certainly, you could say from a qualitative perspective, something lacking. And then the other mystery, coming from sort of the other social end, I would say is twofold. Again, identified from Warren Buffett and Charlie Munger, is they present a strange algorithm. So their strange algorithm, which you might appreciate, is it involves a lot of reading. So it's like, reading, what does reading have to do with finance? I mean, it's like, it's mostly financials. It's a numbers business, which it certainly is. We can't deny that. And I think even a larger social context, which I was rereading some of my texts and I felt underwhelmed, and not underwhelmed as in I was prodded to do better. And there was this larger social context is humans don't think the way they should about decisions. And why is that?
Yes, yeah, that's a very great mystery, and one that we can. I mean, it's when you say business isn't that all numbers, and it's one thing that just give my 2 cents. We can use numbers to fool ourselves into thinking that we've got a kind of mathematical solution to something just because there's numbers there, but that doesn't mean. And a lot of people have fooled themselves into bad decisions over the years by thinking, and I include myself in this, like, well, almost someone freed me from it. I almost made a bad investment decision in my job because I was looking at I was looking at charts, and I was like, oh, look, over time it does this.
Exactly.
But I didn't understand what was going on underneath it.
Right. Yeah. And so the book, a lot of the chapters might come off as strange because a lot of them are not like, I don't think any teacher, any great teacher wants to show how to do like a route calculation, right? That's the proverbial teach someone to fish rather than, showing them how to fish one fish or something like that, right? Or giving them a fish, right? That's the actual phrase. Yeah. So, and exactly that phrase you said about, oh, I was almost fooled, and so when we talk about machine learning, like what is machine learning? What is physics? You have Wittgenstein, who's this language philosopher I'm sure you've encountered. He says, nothing is as hard as not fooling yourself. And then Richard Feynman, the Nobel Prize physicist, winning physicist, he continued with saying, the first principle is not to fool yourself with the kicker, and you are the easiest person to fool, right? It's like, oh, like this is actually the core challenge, right?
Yeah, well, Wittgenstein is a great example because, there's Wittgenstein 1 and Wittgenstein 2, right? Wittgenstein 1 of the Tractatus Logico-Philosophicus is like, I've got some equations dusting my hands off when it comes to knowledge and wisdom. And then he later realized, and then that the Wittgenstein of the philosophical investigations is like just a completely different approach to problems in the world. And one where there's like there's no end to it is very clear. They're not going to come to some final knowledge and that you're going to be done with, and things like that. And so like, I think one of the great lessons of your book is that there's no kind of ultimate algorithm that you're ever going to have and settle on and then just be able to use if I'm not putting too many words into your mouth there. Like that's kind of the challenge. Is not like, to put it crudely, it's someone coming to this podcast might be like, oh, AI is going to do my investing for me now.
Right. No, I don't think that is, completely the truth at all. We have the title of the book, and you can just imagine I'm holding up the physical copy, which it's in another room, but I won't grab it now, is Truth Engine. The idea is the engine needs fuel. And what is fuel? It's knowledge, it's your analyses, it's your thought. And that's very much in keeping with machine learning, right? Machine learning, you have to feed it a lot of high quality data, right? And so you got it.
And so just to go sort of like into the book, I sort of made some presumptuous comments about it in the introduction, but who is this book for?
Yeah, so inspired by people like Charlie Munger and Warren Buffett, it is for a general audience. We took the admonition. So there's another story is when Stephen Hawking was writing was embarking on writing his book, the publisher told him, for every equation you put into it, it's going to reduce sales by, either approximately 50% or 90%, 10x. That in tech, we love 10x, right? You don't launch a product unless 10x. Anyways, and that's an Andy Grove thing. So, so it's meant to be a general audience. I do have to admit, if you look at the trends of books, and this is us talking shop now, a lot of books come out with the abridged version. And so that's probably a to-do for me, is to re-release it as an abridged version, because my bad academic habits, quote unquote bad habits, leak quite into the book. Everything is well cited. Everything is drawn from primary research. And, I think over 40 figures, over 90 citations to primary research. Definitely from that community of professors from, MIT, CMU, Stanford, those type of OpenAI, also into industry. So try to keep it very high quality. Yes.
Mm-hmm. Yeah, definitely. Maybe it is my own academic proclivities as well. I felt very comfortable in this book, but I can imagine that, there might be people who wouldn't. I've heard that there's a theoretical physicist called Sean Carroll, who's got a great podcast called Mindscape, and he says, I'd heard it from him, but I didn't know it came from earlier, that one for every formula, you know, you lose some readers. But there are people who really like it too. And even if they're like me, like they skim the formulas, it actually, talking shop, it does give you confidence that the person, you know, knows what they're writing about. One thing, specific thing I wanted to ask you about, because I think it's sort of a way into other things, is what's intrinsic value investing?
Right. Yeah. So that's that first story, which is how does Warren Buffett tend to make, and he calls himself from this school. So the school of thought, it's value investing, intrinsic value investing, and it harkens back to one of the original progenitors is Benjamin Graham, who wrote one of the first texts on investing and how to value investing. Hopefully I'm getting this right. He's the one who came up with imagining a business as the sum of all its future cash flows, and so you're trying to find that value discounted to the present. So that's a very financial modeling type thing. Warren Buffett's innovation is that, well, as you also pointed out, it's very difficult, and there are many factors that can go into it that are not necessarily quantifiable. Things like, you know, having a wide moat, having a business advantage, you know, having new applications, having you know, monopoly pricing power, having pricing power, maybe not monopoly pricing power, but pricing power. And, you know, at the end of it, you can probably make it too complicated by having products that people want to buy, right?
Yeah, no, for sure. And of course, you know, like a lot of data analysis will go into those kinds of, you know, measurements. But as you say, there's all kinds of other factors at different levels. And so I guess, you know, it's 2024 and everybody's learned about ChatGPT. How is AI being used in the world of investing now, and what are some of the? Can you give us an example of how you would set this out in your book?
Yeah, so we certainly put AI in the title, even though I would say the first half of the book is more machine learning. And so a lot of people say generative AI is a subset of machine learning. What does that mean? I would call generative AI a tertiary tool. So the first tool in machine learning is, when we talk about this in the beginning, it's this train, validation, and test. And this simply, it's like taking an exam. When you study for exam, you take practice exams, and those are like your validation set, and you only get one test at the end, right? And that's like your final test. And really, the whole field of machine learning is about, how can I not fool myself? How can I make an algorithm that rigorously does not fool itself? That is really the entire art of machine learning. And taking this is either Munger, or he borrowed it from someone, is taking a simple idea seriously is actually, you know, colloquially, it's like, oh, the kung fu is deep there, right? The kung fu in machine learning is deep. Generative AI. Why is it a tertiary tool? Well, people have used machine learning to create a tool, and we pull that apart in the book. What is the tool doing? So they've used machine learning to create the tool, and so you can use these, you know, they've done this process of being very good and not fooling itself to do one objective. And what's the objective they wanted to do? They wanted it to match human instructions. So language models do something called language modeling, which is what people normally call next word prediction, right? It's usually measured by this metric called perplexity, which is, if there's a branching factor of what's the next word I'm going to say, you can imagine. And most humans are pretty good. We can probably narrow down the next word you're going to say to within 4 words. But let's say you're not very good at language. Maybe you have you call it a high perplexity. Your perplexity is 100. You could imagine 100 words that I would say next. But honestly, if you know me, and you know, we're in the same context, you probably know what word I'm going to say next, right? And humans are very good at that. So the first breakthrough was language modeling, where they squished that to, instead of 100, they squished it more, you know, to domain of 20, maybe to 4 if the context is really narrow. So that is language modeling, and that it yields you so many great things. Typically, you would say avoiding feature engineering, which is you could spend a lot of time detecting various things, and this kind of does it all for you with this very overreaching objective. But that is not generative AI. What generative AI did is they added on another objective, which is it has to be useful. So they did it through this strange method called reinforcement learning from human feedback, where they really said, we're going to shape it like a sculpture. We're going to shape this model sculpture. So what it actually says, even though it's very good, you could say it's good at language because it can probably say, is to make it useful and that generative AI is a tertiary technique. And what computer science, and so many people say, oh, it's a stochastic parrot. I would say that argument is more accurate for the first phase. But for the second phase, the scientists have done something different. So they say this emerging ability is it's been able to do in-context learning. And that is a very, very powerful concept connected to, now I don't want to ramble, but Bayesian reasoning, generating. Well, this is why we love this problem. When you say, how do we get into this idea of investing? It's an evergreen thing, right? Mm-hmm. It's not something that would be, I think also like publishing new books. That is evergreen. We will always find new ways of thinking because it's very rooted in the language. And so, coming up with investing theses, doing in-context learning, it's an evergreen type of application, and it is as powerful. It lives up to the hype, right?
Yes, and there's an interesting thing, like, when there's something recursive about the whole endeavor, right? Because, when people, like, if you've ever seen a movie about someone who invented a machine that could predict the stock market, for example, well, once it's out there that there's this machine, you have to take into account the machine's predictions and its influence. Once it's known, like if you had the secret machine, maybe it could continue to work. But once it's known that this machine is out there and what its output is, then that's a part of the reality. And this is one of the things that makes investing what it is. And that's why there's no end to it.
Right. That's exactly, this investor, Howard Marks, made that comment as, he's always learning every day. Warren Buffett is learning every day. I can guarantee Jensen reading a tremendous amount, learning every day to improve. If you're standing, the Red Queen book from Matt Riley from days ago is, if you're not running forward in these competitive sort of evolution games, you're getting pushed towards the back, right?
Yeah. And that actually leads me to ask a sort of a question. Like, so like, let's say I'm 20 years younger than I am, and instead of it's 2006 and I'm getting my job as an M&A kind of banker, it's 2026. What sort of machine learning tools do you think I would have, like, just at my desk with me to help make an investment thesis or like come to some decision? Because, like, for example, just to give a very particular example of from my past. So one of the deals I worked on was underground hydrocarbon storage in Germany.
Oh, wow.
So like salt caverns, basically, if you've never heard of it, there's salt domes underneath the earth in some places, and you can shoot water into it to mine a cavern, and then you can store gas in there. And unlike with rocks, the way salt works under compression, nothing can get out. So you can seal gas underground there very well. And now when you're competing in an M&A transaction, like with other bidders, the sort of like, it's your imagination and your knowledge, as Buffett and Munger and everybody else would tell you, is the limit to what you can do is what you know. And so one way we, if I recall correctly, we sort of competed with someone else to get a better price, was we knew there was a chemical plant not too far from one of these salt caverns, and we knew that they could use the salt brine from the mining process to create the cavern in the salt dome. They could use the salty water basically as part of the chemical processes. So now we can sell the salt. We learned about them. We learned they needed this. We learned we could sell the salt water to them from creating the sort of cavern, and that way we could increase the bid price that we had for the competitive process. So is there something that, like, a sort of cowboy kind of like world like that, where machine learning is going to be like useful to have next to me, or like in my computer or in the cloud?
Yeah, that's a fascinating example. Yeah. So first, the disclaimer is our mission is very much fits in the category of, you would call it a smart beta strategy. So kind of like a market-like return. There is another school, very active managers tend to take, concentrated bets, and certainly M&A is one of these fields, right? Yet, so I point to examples where there are cited examples of top M&A firms using these tools. It's all about time to solution, right? So we have this metaphor, or in the book, is if you had an analyst, maybe it's only like a starting position analyst, but an analyst for a certain field, even at a starting position, can add a lot of value. Now, because generative AI has been trained on almost everything, it's like having an analyst for every domain, which is, you couldn't go out and hire 1,000 analysts and have them at your fingertips, right? Unless you had some sort of enormous resources to start. And so this is great for small firms, right? And so that is a tremendous goal. And we cover this matrix. This was originally proposed by Donald Rumsfeld, is to get at this problem, to know what you don't know, right? To cover, and in context, you can, it's stupid, but you can ask it like, are there other sources of alpha that I can pick out in this deal? And so maybe not a guarantee at all, but at least probably at the kind of entry level analyst, you could start making inroads on that. And I actually absolutely love that, and using that for thesis generation.
Right. Yeah, no, that's really excellent. I'm actually looking at the page right now in your book near the beginning where you talk about the junior developer Ernest, which is the example you're talking about. And you have the great line that the power of generative AI is that it applies to the vast majority of knowledge work all at once. So like you're when you're asking it these questions, it's got so much like ingested already that you can't, it doesn't mean you sort of do what it tells you, but you use it as this tool, like an analyst or 1,000 analysts. I love that image.
Yeah. And I think the scenario here you mentioned is, it's this, another investor loved this term of it, has a bit of latent knowledge. So in your example, you had that team that had, between the group of you had that latent knowledge. It's like, we know of various add-ons, various horizontal plays that would, lift the economics of the deal, right? And it's, certainly you always have to look for a different edge. People call, what is your edge? Well, maybe it's the breadth of your knowledge, right?
Definitely. Also, maybe to move on to the next part of the interview, the ability to tell a story, which is something that is, I think, often very much overlooked, because part of there's investing your own money, and then there's convincing other people to come along with you. And in order to do that, you have to be able to do a lot more than show a chart.
Yes.
You have the deep knowledge and an explanation to give when people ask questions. And if you've ever been standing in front of an investment committee or something like that, that 2 questions in, you might be lost. And having, even when something you've been working on for a long time. And I just bring up telling a story because you've written this really great book. And I was just wondering if you could talk a little bit about what your approach was to writing it. Are you a sort of outliner? Like you had like every chapter and every subheading kind of set out in advance? Did you set aside like, Saturday mornings for working on it? What was your general approach to it?
Oh, yeah. And thank you for those very, very kind comments. I hope, my first hope is that it's useful to somebody. So getting into that hands. Yeah. So the writing process, one of the things that pushed it forward was I had a bad bout of RSV and Corona Omicron that kind of waylaid me, and that allowed me to marshal some resources to exactly do as he said, to kind of outline my thoughts more concretely. I had known I wanted to. It was getting to the point where I felt unsatisfied if I had only given a partial answer, and to finally collect a full answer to how I want to answer those twin mysteries in the beginning. And then to be straightforward, it actually one thing that kept it going, along quite well, and it's one of the acknowledgments at the end, is the project was actually in process at Columbia Business School with, I have to mention that the excellent publisher, Miles Thompson, who gave some fantastic feedback and guidance. We didn't end up going with them due to, in software, you work a lot, the kind of the IP rights, and then that's the appeal of Leanpub, right? These great, to retain those IP rights, it's like, maybe cheekishly, it's like if I wanted someone to own the IP rights, I could have just stayed at my job, right?
Right.
At my original job, right? But so yeah, though that's not true. Certainly, I actually know a lot of the appeal of the publisher, which I, jump off the cliff first and then you learn later, unfortunately, but for better or worse. But yeah, and so those processes brought it through. So that is a very traditional process where, especially, it also counts as academic publishing. You submit a proposal. And so they do ask you all these things about what is each chapter going to have in it?
Right.
What do you plan to discuss? And then, you write the first chapter, and then they send that chapter out for peer review, and along with the proposal, and it comes back. And so after passing that, you get issued the contract. So that, I think, even that would just sharpen it enormously. And and certainly going through the full process, those headings changed, right? It's like, oh no, maybe I had one that was maybe focused on data engineering that I wanted to tweak in some way, or maybe I want to talk about databases a little bit too much, and I said, scratch that. That could go into the more technical edition later on, or something like that. So certainly a lot of that helped. Talking on writing is so this is the thing, is people I love about markets and the modern day is someone else has done a great. That's actually how I found Leanpub. It's like someone else has done a great job, and I found you guys. And so on writing, someone else has done a great job. Stephen King, even though I dislike his books, his book on writing is that's my favorite book of his. Right. That is a really excellent book, one of the best, and I think there are a few others. Reading about how Ernest Hemingway, I love his writing, came to his books, and he actually had a great collaboration with his publisher, which I keep going to that, but yeah.
Yeah, no, that's a really great description of a really great process. I think Roger Ebert might also have written very well about writing as well. I'm with you on Stephen King.
Yeah.
It's sort of funny. But yeah, no, that process of getting something out there, like getting a part out there first in front of other people before completing an entire book is a battle hardened sort of process that I think both, academic PhD supervisors have that too. And so do publishers. And partly what they want to know is, can you write? Can you stick to a plan? Things like that. But from the the other sort of maybe perhaps partly unspoken part of it is you getting to know the publisher as well. And do you like their process before you commit to a full plan, which can take years and can have setbacks and disagreements and things along the way. So you getting to know your project, them getting to know you, those are all a very, very important step. And it obviously baked into the whole Leanpub process is, you can do it various ways, but the lean publishing idea is write a couple of chapters, put them in front of somebody somehow first. And it can also very much help for motivation and validation and things like that. I'm on the right track, things like that. And more importantly, talking shop, to us, one of the best outcomes is when someone stops working on a book because they wrote 3 chapters. My old kind of joke is you wrote the expert's guide to model trains and you publish it and no one wants it, but 1,000 people are if you'd only written the beginner's guide, I'd have been there with you. And so if you publish a few chapters in on any topic, you can get feedback from people that are actually, that's great, but there's actually a need for this other thing out there. Yeah, well, the book is really good and really interesting. I can't stress that enough. It's Truth Engine is the title. We were really glad to see it pop up on Leanpub, and we're really looking forward to seeing the book's journey and yours as well. So thank you very much, Leo, for being on the Leanpub Front Matter podcast.
Thank you for having me.